What if you could produce any tool or utensil right in front of you when and where you need it? The Marshall Space Flight Center has teamed with a company called Made in Space to do just that, to build a 3D printer for the astronauts on the International Space Station. We caught up with folks who are gearing up for an in-flight test to find out just how tricky it is to build a printer to use in microgravity.
Space in general has some unique challenges, and one of them is microgravity. Things change in microgravity. You don't have, fluids don't separate due to their heating characteristics. There's no convection. So with a thermal process, such as what we're doing with a 3D printer, that becomes very important. So from that standpoint, we had to figure out, what do we need to change there? And also, mechanically speaking, our machines is different from those on the ground, mainly because in gravity you don't have things holding things down, and we have to reduce and eliminate the amount of variation in our system as much as possible.
And for a while, NASA has been wanting to grow the area of in-space manufacturing. There's a lot going on in this arena, as we all know. You hear a lot in the news about 3D printing. We have the way we put the handle is we have for space, which are things like currently we're printing parts for SLS, the SLS vehicle, that are additively manufactured. We call those the for space, so aerospace parts that we actually print on the ground. And then I actually work the in-space manufacturing, so all the types of things that we could use on station, but also those things that we need to develop for exploration capabilities down the road if we're on the moon or Mars or an asteroid mission. And we can test a lot of those on space station. It serves as a test bed.
We learned quite a few lessons. Patience is the most important one. We had to actually analyze what we were doing in our microgravity flights with the hardware, what was changing between our commercial ones and when it went from the ground to that environment, and understand what was changing mechanically as well as the material phenomena that were going on. And we got a clear understanding of that, and we applied that to this device. Some of the things we have to do to our machine to help verify it, so that way we know it's okay when it launches. So we went through EMI, electromagnetic interference tests, and compatibility tests. We've gone through vibration tests where we put it on a shaker and see if it can hold up to the strenuous launch environment. We've done emissions tests where we see, while it's operating here, what is this doing to the machine itself, the glove box, and the things around it. We've done a full circuit of integration test with the glove box, which is, just to make sure it works, because this is identical to the one on orbit. So we plugged it in, and as you can see, it's printing now. So that test was, firsthand experience. You guys get to see that it's working. The ISS is a unique platform, right? You can test things for long durations in that environment. For us, we're trying to see if these things we've learned apply still to the long duration environment. But technology and sciences are being explored every day that's going to help us along the line. And the commercialization aspect of that is really important because when we have a permanent facility up here, there's pharmaceutical research, crystal research that's going on, and those experiments can actually benefit from our device, and we can sell those services to help iterate. That's one thing that space really lacks right now is rapid iteration. It takes a very long time to iterate your experiment. You can't build them very quickly to get up there, but once this capability is fully utilized, you'll be able to update your experiment or make a new one relatively quickly, which will open the doors to more things on ISS, which benefit us right down here on Earth.
The technology is very exciting, there's no question about that, but working with a small company like this, whose whole business model is to develop a business in space, using the space station as a very unique laboratory and test bed, the only kind that we have of its kind. Working with them and being able to provide NASA insight and guidance. They are developing the hardware and designing the hardware. However, NASA has really helped to kind of translate our spaceflight requirements, our certification process. NASA has a very, as you might imagine, stringent flight certification process from a safety perspective. But not only that, operations. So on the ground, you don't think twice about running over and grabbing your print. And if you need to level your printer, you can turn some screws. But on space station, crew time is very limited. And so we really have to design in such a way that we have as much autonomy as possible. So on our flight printer, we can actually do commanding from the ground. We can uplink a file and print what we need. And we've really kind of limited how much crew interaction is needed.
What I would recommend to companies that want to fly their own stuff or thinking about flying their own stuff to space station is to, address NASA directly, get some advice. There's multiple paths to actually get there, and we took an SBIR route, which is just one mechanism to get our payload up there. But there's other opportunities out there, and talk directly to who you think is going to be interested and try to get your stuff flown, and then get advice from as many people in the space industry as possible, from either be NASA or a private company that has experience, because it's going to help you along the way.